Lately, this news has caught the attention of many. Scientists have discovered potential signs of life in the atmosphere of an exoplanet. They specifically detected dimethyl sulfide and dimethyl disulfide, with notably high concentrations. These organic compounds are quite unique because on Earth they are almost exclusively produced by biological processes like those involving marine plankton. And coincidentally, scientists had previously speculated that this planet is likely just such an ocean world with abundant liquid water. In 2015, the Kepler telescope, dedicated to the search for exoplanets, embarked on a new phase known as the K2 mission. During this time, astronomers discovered a planet orbiting a red dwarf star 124 light-years away in the constellation Leo. Because it was the 18th planet discovered during the K2 mission, it was named K2-18b. Observational data reveals that this planet has a mass approximately 8.6 times that of Earth and a radius about 2.6 times larger. By classification, it can be considered a super-Earth. In 2017, the Spitzer telescope provided further confirmation that K2-18b is situated 0.15 astronomical units from its parent star, which is less than half the distance from Mercury to the Sun. At first glance, this seems quite close, but despite its proximity, it is perfectly positioned within the star's habitable zone. This is because its parent star is a red dwarf, possessing only half the mass and radius of the Sun. As a result, the planet receives a light intensity approximately 1.28 times that of Earth, making its conditions very similar to our own. Currently, the Earth Similarity Index for this planet is evaluated at 0.73, which is relatively high among exoplanets. After all, Mars only scores 0.7, so a unique alien planet like this really deserves a closer look. The planet is not too far from us, being only 124 light-years away, and it has a very short orbital period of just 33 days. So scientists plan to analyze its transmission spectrum to find out what's in its atmosphere. Transmission spectroscopy means that when a planet passes in front of its star, some of the starlight passes through the planet's atmosphere. Different molecules in the atmosphere absorb various wavelengths of light, leaving distinct features on the spectrum. So, by analyzing the transmission spectrum, we can figure out what makes up the planet's atmosphere. In 2019, a study published in Nature Astronomy revealed that researchers used the Hubble telescope to perform transmission spectroscopy on 8 transits of K2-18b. They successfully detected hydrogen in the planet's atmosphere, along with signs of water. Based on the characteristics of this planet, scientists have defined a special type of planet. The name comes from combining the words hydrogen and ocean, and it describes a world with a liquid ocean beneath a hydrogen-rich atmosphere. You might also refer to it as a hydrogen ocean planet. Although our solar system lacks such planets, astronomers believe they are quite common in the universe and are considered promising candidates in the search for extraterrestrial life. In 2023, scientists continued their exploration of K2-18b's atmosphere using the powerful Webb telescope. This time, they discovered strong signals of methane and carbon dioxide in the spectrum, marking the first time carbon-based molecules have been found in the atmosphere of an exoplanet within the habitable zone. Additionally, the absence of ammonia detection in the atmosphere thrilled scientists, as ammonia easily dissolves in water. Since no ammonia was detected in the atmosphere, it's very likely that it was absorbed by the liquid water on the planet's surface. In other words, this planet really could be an ocean world. Adding to the excitement, scientists identified the presence of dimethyl sulfide, a significant indicator of life, through Webb's near-infrared spectroscopy. Although the initial statistical confidence was low at about 1 sigma, a recent paper in the astrophysical journal Letters revealed that researchers using Webb's mid-infrared spectrometer detected dimethyl sulfide and dimethyl disulfide again, with a confidence level of 3 sigma. On Earth, these compounds are primarily produced by life, particularly marine ecosystems, so their presence in an exoplanet's atmosphere naturally leads to speculation about the possibility of life, especially on an ocean world like K2-18b. Moreover, this time they discovered not just these 2 organic molecules, but found that at least one of them exists in exceptionally high concentrations, thousands of times greater than what we find on Earth. If these molecules are truly the result of life processes, then the ocean on this planet doesn't just harbor life, it could be brimming with it. Alright, after we've covered the thrilling parts, let's move on to the uncertainties. First off, while the confidence level of this result has reached 3 sigma, or 99.7%, which seems quite high, it still falls short of the golden standard of 5 sigma, or 99.99994%. Therefore, we can only refer to this as a potential discovery rather than a confirmed one. Furthermore, even if future results do meet the 5 sigma standard, it still wouldn't be direct evidence of extraterrestrial life. This is because the origin of these organic molecules is still uncertain, and we cannot rule out the possibility that they were created through other non-biological processes, for instance, volcanic activity and certain photochemical reactions. On this point, the research team is also working with other teams, trying to find ways for non-biological processes to occur in the laboratory. Let's talk about environmental factors. While K2-18b is located within the habitable zone, the definition of this zone is often quite rough. It's simply estimated based on the star's brightness and its distance from the star. It assumes the star gives off energy evenly, but in reality, stars aren't nearly that well behaved. This is especially true for small stars like red dwarfs, which are entirely in a convective state internally. As I mentioned before, Proxima Centauri flared 463 times over 2 days, averaging less than 1 flare every 10 minutes. Although a few flares might not be lethal to life, you can't keep bombarding it endlessly either. In addition to the influence of stars, the environmental factors of the planet itself are crucial. For instance, Earth's atmosphere is primarily made up of nitrogen and oxygen. If these were replaced with hydrogen, like on K2-18b, the collisions of hydrogen molecules would absorb infrared radiation, causing Earth's temperature to rise significantly, potentially leading to boiling oceans. Unfortunately, all known ocean planets with hydrogen atmospheres are currently situated in the boiling zone. Therefore, whether they truly possess liquid oceans remains a mystery. Oh, you might wonder, didn't we just mention that water can absorb ammonia, and the lack of ammonia suggests oceans are present? Keep in mind, that's assuming the conditions allow for liquid water to exist. If the planet's surface temperature is extremely high, like being covered in magma, then ammonia would naturally struggle to exist and would have already broken down. In summary, the current research on K2-18b is still primarily focused on understanding the planet's structure rather than exploring extraterrestrial life. After all, we need to have a basic understanding of what the planet's surface is like before we can discuss the existence and nature of life there. Nonetheless, this discovery stands as the most convincing evidence of extraterrestrial life to date. If one day we can confirm that extraterrestrial life truly exists on K28b, it would show that life really is a common phenomenon in the universe, including intelligent beings like us humans.